Okay, so your x value is 9, and your y value, you can calculate that. Negative 0.39 times 9 plus 7.27, and what you get is 3.76. Okay, so during week 9, based on your behavior, you can expect to be going to the gym 3.76 weeks. Okay, as discussed, if your behavior is a good model for your friend's behavior, then by week 9, you can expect them to be going to the gym less than 4 weeks. Okay, between 3 and 4 weeks. So you can make a bet saying, okay, I bet you're going to be going less than 5 times a week on average by week 9. Okay, now similarly, if you want to know, well, how often will someone be going after 10 weeks? Okay, x equals 10, y equals negative 0.39 times 10 plus 7.27. Okay, and you just plug that in to a calculator, or you calculate it in your head, and you get 3.37. Okay, so during week 10, you can expect to be going to the gym 3.37 times. Okay, now if you look at the difference between those two values, okay, between how many times you go on week 9, how many times you go on week 10, the value actually went down by 0.39. Okay, x increased by 1 and y decreased by 0.39, which is exactly what you would expect, because negative 0.39 is the slope. Okay, and you can actually have a different kind of question, which you might ask based on this equation, is how much will gym visits per week change or increase or decrease in a span of, say, 5 weeks. Okay, so what's being asked here is not how many gym visits will there be during a particular week. What's being asked is how much will gym visits change if 5 weeks go by. So we're not asking for the actual value, the number of visits. We're asking for the change in number of visits. Okay, well, for 1 week, it's negative 0.39. For 5 weeks, it's going to be negative 0.39 times 5. .39 times 5 is 1.95. Sorry, negative 1.95. Okay, so 5 weeks go by, you can expect someone's gym visits to decrease by approximately 2 times a week. Again, assuming your behavior, the data that you collected based on your behavior, is a good model for someone else's behavior. Okay, now, of course, a better plan for your study is, rather than looking at one person and what was their number of visits per week, you'd look at a larger group of people. And for every week, you look at, okay, on average, how many times did this group go to the gym on week 1? How many times on average did they go on week 2? And so on. That would be a more reliable study. Now, the other thing we can look at is this R squared value. Let's say we do have a more reliable study. Okay, so this number for week 1 is not how many times you went to the gym. It's how many times, say, a group of 100 people went to the gym. On average, they went 6 times. Okay, during week 2, on average, they went 7 times. Maybe some of them went more than 1 time a week. Okay, and 1 time a day, right? And so on. All right, so we have a reliable study. We still ask the question, okay, well, how reliable is our linear regression? And that's what this r-squared value tells us. That's our coefficient of determination, which is 0.64. Oh, 0.647, okay. So our r-squared value, 0.647, okay? Which is not an incredibly strong correlation, but it's definitely a correlation of reasonable strength, right? So there definitely is a negative correlation, okay, between the time since the new year and how diligently are these people actually fulfilling their gym-related New Year's resolution, all right? Now, sometimes we talk about the correlation coefficient instead of the coefficient of determination. The correlation coefficient, that's r, which is just the square root of r squared with a negative sign or a positive sign depending on if your correlation is positive or negative. Now in our case, we've got a negative slope. So we know it's a negative correlation, so r has to be negative. So our coefficient of determination is going to be the negative square root of 0.647. And that value is negative 0.8. I'm rounding here. Okay. Now, the correlation coefficient is going to be between 1 and negative 1. The closer it is to 0, the weaker your correlation. The closer it is to 1 or negative 1, the stronger your correlation. And if it's negative, it means it's a negative correlation. If it's positive, it means it's a positive correlation. So in our case here, we have a relatively strong negative correlation. Relatively strong because we have 0.8 as our r value, or 0.64 as our r squared value. And it is a negative correlation because our slope is negative, and so our r value also has to be negative. If our slope was positive, then our r value would have to be positive. Okay? So for example, maybe as you look at summer months approaching, beach season is approaching, and you look at the weeks since April 1st, okay? Weeks since April 1st. Weeks since April Fools, okay? And that's what our x value represents, right? And our y value represents gym visits, and we plot our data. Okay, so let's say 1, 2, 3, 4, 5, 6, 7, 8. And we've got 4, 3, 6, 5, 6. 7, 5, 7. Okay? 4, 3, 6, 5, 6, 7, 5, 7. 4, 3, 6, 5, 6, 7, 5, 7. And let's add some more values here. Okay. So now things are trending upward. Okay? We have a positive slope now of 0.14, I'm rounding, and our y-intercept is 4.55, rounding again. All right, now our r-squared value is 0.12, okay? So, if we were to write our equation, it would be 0.14x plus 4.55. 0.14x plus 4.55. And our r squared value was 0.12. That's our value right here. We're rounding 0.20, not 0.12, 0.20. So let me fix that there. .20. Just making sure we have it right there. So now you might ask, okay, how many visits to expect after 4 weeks? Okay, well, you just set x equal to 4, y is equal to 0.14 times 4 plus 4.55 which is 5.11. 5.11 visits on week 4 since April 1st. Okay, you might ask, how much do visits increase in, say, 2 weeks? Okay, so it's not asking for the number of visits during a particular week, but just how much does the number of visits increase if 2 weeks go by? Well, it's 0.14 is how much it increases in 1 week. So in 2 weeks, it'll just be 2 times that, which is 0.28, not very much, okay? And you might ask, what is the correlation coefficient? Well, r equals the square root of r squared, but this time it's the positive square root because your slope is positive 0.14, so it's a positive correlation. There you have it, right here. So it's going to be the positive square root of the r squared value, and that r squared value is 0.2. And the square root of 0.2 is 0.45, again rounding. Okay, now, is there a positive correlation or a negative correlation? Well, the slope is positive, implying a positive correlation, but the r squared value is quite small, 0.2. Okay, and we see that in our r value, it's closer to 0 than it is to 1, 0.45. So the correlation is there, but it's really not that strong. It's a pretty weak correlation. And when we look at the data, we can tell by the naked eye it is a pretty weak correlation. It does trend upward initially, and then it kind of sticks around the same place on top. Now, why is it sticking around the same place on top? Okay, well, there could be a number of reasons depending on the data you're looking at. In our case, people who go to the gym regularly will typically go once, or they won't go more than once a day. And there's only 7 days in the week, right? So we do have that cap there at 7, and that's why the data won't increase above there. So what this tells us is that once you get to 6 or 7 weeks past April 1st, the relationship isn't linear anymore. Okay, so your linear regression may not be the best way to look at the data beyond, 6, 7 weeks after April 1st, right? So once you're in the middle of May, right, closer to the end of May, then maybe you shouldn't be using the linear regression beyond that. But if you were to look at, say, end of March to middle of May, then linear regression might be more useful.